Limit is y goes to 0 of the cosine of y minus 1 over the sine of y. The first thing we're going to do is try plugging a 0 in for each y, so that will give us the cosine of 0 minus 1 over the sine of 0. The cosine of 0 is a 1 minus 1 over the sine of 0, which is a 0. 1 minus 1 is 0 over 0. So we have the 0 over 0 indeterminate form. This is resulting from trig functions. If you look, neither of the trig functions is in a square form, so we don't have any Pythagorean identities. Neither of them have a 2y, so we don't have a double angle formula to use, so there's really no identities left to use to convert these. However, in the numerator, we have a trig function added or subtracted together with another term, usually a 1, and that's an opportunity to make use of the trig conjugate. The trig conjugate is the same trig combination, but with opposite sign between the terms. And I'm going to put it over itself so that we have a form of 1, so that when we multiply, we don't change the value, we just change the look. And we have limit as y goes to 0 of. Now in the numerator we have trig conjugate pairs, so we will FOIL that out. First, cosine times cosine is cosine squared of y. Outside, cosine of y times a positive 1. Inside, negative 1 times a cosine of y, and then last, negative 1 times a positive 1. In the denominator, we do not have trig conjugate pairs, so we will not FOIL or distribute. We will leave it in its factored version. Now, trig conjugate pairs, when FOILed out, the outside and inside terms are equal value but opposite sign, and they will cancel each other out. Now we still have 0 over 0. We haven't changed that, but the difference is we now have in the numerator a Pythagorean trig identity. Now in the denominator, the 0 is happening because of the sine of y. In the numerator, it's happening because of the cosine squared of y minus 1, but because of the identity, that can be converted over to something involving sine, and then we can get sines to cancel. So that's going to be our next step. Now, the Pythagorean trig identity is sine squared y plus cosine squared y equals to 1. So if we rearrange this to get cosine squared of y minus 1, that will equal negative sine squared of y. So what we have after replacing is negative sine squared of y in the numerator over sine y times cosine of y plus 1. We still have 0 over 0, but we have the ability to cancel one of the signs from the numerator with that from the denominator, like so. At that point, we should no longer have the 0 over 0 indeterminate form. I'm going to rewrite what we have left over, and that will be negative sine of y over the cosine of y plus 1. And we should be able to plug a 0 in for the remaining y. So we have negative sine of 0 over the cosine of 0 plus 1. The sine of 0 is a 0, so we have negative 0. Cosine of 0 is a 1. 1 plus 1. The negative of 0 is just 0. 1 plus 1 is a 2. 0 over any non-zero number equals to 0.